Welcome to Math with Mrs. Bibb. Today I will be discussing linearity and continuity of graphs, along with intercepts of graphs. First, we'll define a discrete function. And a discrete function is, when we're looking at a graph, when the points of a graph are not connected. Students will oftentimes ask me when they're given a relation, and you don't have to write this, so you don't have to write this. When they're given a relation that looks like this, 1, 2, 4, 7, 3, 5. And then they'll plot those points. I'm going to plot them very, very roughly. 1, 2, 4, 7, 3, 5. Students will often ask me, do they have to connect the dots? And the answer to that is no, do not connect the dots. Now, of course, if you want to write that down, you're welcome to, but it is not required to write what's over here in this corner. So a discrete function is a function in which the points are not connected. Now, I do not remember, yes, I did mention in the last section, the vertical line test. So don't forget that. It's a function because it has passed the vertical line test. And this one here has passed the vertical line test. Someone showed me a cute little thing to remember if something is a function or not, if you have a relation, a list of ordered pairs. So if your x's repeat, it's not a function. If your y's repeat, it's okay. It can be a function. So that's really cute. If your x's repeat, it's not a function. If your y's repeat, it's okay. And you don't have to draw that on your paper, but I thought that was cute. Okay, continuous function. Points are connected to form a line or a curve. And you will know to connect those points if you have an equation. So first of all, if you have a graph and the points are connected to make a line or a curve, then you know that that's a continuous function. But if you have an equation like y equals 4x plus 2, that is a linear continuous equation. So you connect the dots when you have an equation or the dots are already connected, like this example down here. And then neither discrete or continuous is when some points are connected by a line or curve that's not continuous everywhere. So I'm going to say not continuous everywhere. And then I don't remember if we mentioned domain and range in the last, yes we did. So domain and range was in that last section. So I want to talk about domain and range for each of these types. Remember, domain is your x values, range is your y values, and I'll mention the domain and range underneath these problems. So first we're going to decide if the following functions are discrete, continuous, or neither. So the first one here on the left, this one is discrete because it's just a set of points. And the domain and range for both of these is just the set of individual values. So you should write all that down. And when you make that set, you use the braces. The set of x's for domain, the set of y's for the range. That's how you write the domain and range for this. And then for the second one, this is neither discrete nor continuous. So I'm just going to put neither. It's because it has a piece that continues forever. It has one dot, and then it has another piece that stops. So it's neither discrete nor continuous. The domain and the range for this varies based on what's graphed. And then this next one, that is a curve connected by points, and so this one is considered to be continuous. And our domain, and we'll grab a highlighter. Our domain, remember, is how far left or right a graph goes. And this graph is slowly opening forever to the left and forever to the right. So that domain is all real numbers, or negative infinity to positive infinity. And then when you look at the range, how far up and down is this graph going? Was going forever up and forever down. So the domain is all real number, the range is all real numbers for that as well. So just remember, if you have a curve that looks like this, the domain and the range both are all real numbers, or negative infinity to positive infinity. And I'm going to write that down. Domain and range, all real numbers. And then this last one, it is a continuous graph. And how far left and right does this graph go? It goes forever to the left and forever to the right. It's slowly opening forever left and right. But how far up and down does it go? Does it go forever up? Yes, these are pointing forever up. But does it go forever down? No. So the range is just a little bit different. The range is one interval of real numbers. And the range, of course, is all real numbers. I think I said range. The domain, of course, is all real numbers. Okay, on to the next page. Or next part. I know it's one page for you all. We're going to define linear function, equation, graph, table, all those lovely things. Linear equation, slope-intercept form, standard form, and nonlinear function. So a linear function is a function that has a graph that is a line. A linear equation can be used to describe a linear function. Then as I look at these, if you have a graph, remember, how can you tell if you have a function? It has to pass the vertical line test. If you have a graph to be a function, it has to pass that vertical line test. Now, to pass a vertical line, remember vertical is this way, can only pass through the graph once. If it passes through twice, then it fails the vertical line test. For a table to be a linear function, then you have to have no x values repeating. I think up here I meant where it says can be used to describe a linear function, and you don't have to, you can draw arrows. I'm going to erase. I'm going to put that down here. But you can draw arrows and write the other in the other spot, in this spot here where I'm writing. Can be used to describe a linear function. Then I'm going to erase up there. If you want to erase so yours will look exactly like mine, that's perfectly fine. So to pick back up where I left off, I should have written here that an equation, you know you have a linear function in equation form when you have no exponents other than 1. And be very careful, because if you have this, that is an exponent other than 1, because technically that is y equals x to the negative 1. If you have this, then you have y equals x to the 1/2 power. So be very, very careful. Also, I hope you can squeeze this in. If you have two variables multiplied, that is not a linear function, despite the fact that when you look at this equation, there's no exponent other than 1. But you cannot have two variables multiplied. You can't have a variable in the denominator. That means you have a negative exponent. You can't have a variable under a square root. That means you have 1/2 as an exponent. So I apologize for that, but it is perfectly fine if you draw arrows between these two and switch those around. That is perfectly fine. Now, slope-intercept form. Hopefully you remember that's y equals mx plus b, where m is the slope and b is the y-intercept. Standard form you may not have ever heard of before, ax plus by equals c, where a, b, and c have to be integers. And a has to be greater than 1. And a nonlinear function has a graph with a set of points that cannot lie on the same line. Has a graph with a set of points that cannot lie on the same line. Okay, moving right along. For a table, no x values repeat. Also, you are looking for a constant rate of change. That's how you know you have a table that is linear. To be a function, first it has to meet this no x values repeat. And then to be a linear function, you're looking for a constant rate of change. Determine if the following are linear or nonlinear. So let's look at the first one. I can't tell what that says. Oh, hold on. I think that says, no, I still can't tell. Y equals, yes, okay. I just moved it over. Okay. When I look at this first one, I see something I need to simplify before I can decide. So I need to simplify that. Y equals 4x squared minus 2x times 2x. That's what this means. That's 4x squared plus 3x minus 5. These will combine to make 0. So I have y equals 3x minus 5. Is that written in one of those forms that is said to be linear? We do have no exponent other than 1. We also have no variable under a radical, which means we'd have an exponent of 1/2. So this one is linear. The second one, can I simplify there? these two do appear to be like terms. Oh, actually, they are like terms. We can simplify the square root of 9. 3x squared, the square root of 9 is 3x, so minus 3x minus y equals 17. 3x squared minus 3x squared minus y equals 17. And then these two will combine to make 0. So negative y equals 17. Negative y would equal negative 17. Oops, positive y would equal negative 17. So that is in the form y equals mx plus b. The slope is 0. The y-intercept is negative 17. So that means this one is linear. Now, does that work out for this next one? 3x cubed minus x cubed, is that going to be 0? No, we have y equals 2x cubed plus 3x plus 0, which means I have an exponent other than 1, and this one is nonlinear. Now, did I write down over here? Let me go look. So let's look at this one. Check your x values first, or in this case s. Are these increasing by the same amount? And hopefully you can see that yes, every time you're adding 0.5. Then are these increasing in the same amount? That increases 16. No, 26. This increases 26. Is that right? 46 minus 28. Nope. 60 minus 8 is 8. 18. So this one's a no. So it is not linear. This one is non-linear because it does not have a constant rate of change. X-intercept, remember, is where a graph crosses or touches the x-axis. So I'll write that down in just a moment. X-intercept is where a graph crosses or touches the x-axis. Try to put an R there. Crosses. Oh. Or touches the x-axis. Main thing to remember is y equals 0 for the x-intercept. For the y-intercept is where a graph crosses or touches the y-axis. And you have to remember that's where x equals 0. And then this graph over here, you may want to grab a highlighter, 2 different color highlighters. If you need to borrow one from me, that's perfectly fine. But I want to show you what it means by positive and negative. It says a function is positive when its graph lies above the x-axis. So this is where it's considered positive. And then when it lies below the x-axis, that's where it's considered negative. So positive when its graph lies above the x-axis. And it's negative when its graph lies below the y-axis. Excuse me, x-axis. Its graph lies below. So above for positive, below for negative. We are going to find the x and the y-intercepts of these functions, and then we're going to describe where the function is positive and negative. So for this first one, the x-intercept is 1, 2, 3. So you can either say 3 or 3, 0. And then the y-intercept, you can either say 1, 2, 3, 4, 5, 6, 6, or 0, 6. Either one of those is acceptable to me. I think your textbook gives the ordered pairs, but it's acceptable to me to say 3 and 6, or 3 or 6 for intercepts. So I want to shade above the x-axis. That's positive. And below the x-axis, that's negative. So I'm going to say that from the point 3, 0, that this function is positive for all values x is less than 3. That's all the values of x less than 3 is where the graph is above the x-axis, and then it's negative for all values x is greater than 3. As you are going to the right, getting bigger away from 3, then the values are of this line, this blue line, are in the negative area in the yellow. Okay, let me grab a highlighter and color on the next one. Positive, negative. Let's do the intercepts first. The x-intercepts, because it crosses the x-axis twice, appears to be -4 and 3. And the y-intercept looks like 12 to me. -4 and 3. And then, like I said, the y-intercept looks like 12. And it is positive in a couple different places. For all values less than -4, x less than -4, and when x is greater than 3. That's when it's positive, and it's negative when x is between -4 and 3. And the best way to write that, this is between -4 and 3. And let's go to the next one. I'm going to highlight first. Positive in this area and negative in this area. So the x-intercepts are +1, +1, and +4. And the y-intercept, 1, 2, 3, 4. The y-intercept is -4, and it is positive for numbers between 1 and 4. Positive for all x values between 1 and 4, and it's negative for all x less than 1 and x greater than 4. 1, 2, 3, 4. A root of an equation is any value, so any value that makes the equation true. That's what a root is. Any value that makes the equation true. Oops. And a 0 is an x-intercept of the graph of the function. Now, a 0 would make the equation true also. And so there are several synonyms that you need to know. If you are solving, then you are finding the solution, you are finding the roots, you are finding the zeros, solutions, roots, zeros, x-intercepts. So, you can put any equation into Desmos. We're actually going to put them into linear form, but you could actually just put it into Desmos. I'll show you. And it will give you the x-intercepts. Now, make sure that you use Desmos graphing. That's what is used in the high school, and it's used on the SAT. So make sure when you search for this that you search for Desmos graphing. And it'll look like what you see at the bottom of the screen. Now what we're going to do, we're going to find the related equation, which means we're going to make it equal 0, and we're going to replace the equal 0 with f of x, or g of x, or whatever the function name is. But I am going to show you that actually when you're taking a standardized test that you can use Desmos on, you do not have to put it in that form. Okay, so I am going to subtract 1. It's going to make that equal 0. Negative 2x plus 7, plus 6 equals 0. So I'm going to have f of x equals negative 2x plus 6. And all I have to do, and I'd like for you to do this also, so make sure that you go to Desmos and do this also, because I really want you to understand and know how to type this in. You can use your keyboard. I don't have a keyboard as I'm writing on this iPad, so you can use your keyboard, or you can do this little pull down menu. It's right there. I just made it disappear. Hold on. Took me, there we go. It's right down here. There we go. There it is. I'm trying to get it to work, but you know, browse. Okay, so it's that menu right there. The keyboard comes up. And I'm going to just type in negative 2x plus 6. And the solution is the x-intercept. Well, the x-intercept is 3. So x equals 3. And I just solved that by graphing. Now go back just for a minute and solve that in your head. Subtract 7. So negative 2x would equal negative 6. Divide by negative 2. X would be equal to 3. I also want to show you that I can that I can I want to get this thing to work. There we go. Just type in negative 2x plus 7 equals 1. And that is a different graph. Did I type something wrong? Interesting. It has the same y-intercept. Oh, I know why. I know why, and that's okay. Yeah, I know, but you can see here that it did give me that same solution. So the graph may be different, but it did give me the same solution. Okay. Let's look at the next one. We're going to make the related equation. So we are going to add 3 to both sides. I'll have x squared minus 4x plus 3 equals 0. And that means I have g of x equals x squared minus 4x plus 3. I keep trying to make that little dot go away. There, it worked. Okay. Now I'm going to get rid of that one, get rid of that one, and I'm going to type in x squared I hit the little a to the second power for the squared, minus 4x plus 3. And look, I have 2 intercepts, 2 x-intercepts. So the solutions are 1 and 3. I want to enter that equation as it was. I don't remember what it looked like. Let me see if I can find it. Find my piece of paper. Here we go. So x squared minus 4x equals negative 3. So the graph looks different, but it does have the same x-intercepts. So I do believe that will work 100% of the time. And now let's do this last one. Negative 4x, subtract 4x, subtract 4x. So subtract 3, subtract 3. I have 0 equals negative 8. And we know that that's no solution, because that's a false statement. But I want to show you by graphing. So I'm going to replace the 0 with f of x. Or let me not use f because I've used f already. Let's use h of x. So h of x equals negative 8. Now let's graph that and verify that the answer is no solution, that it does not have an x-intercept, because that's what's true when it has no solution, is it does not have an x-intercept. Okay, so I'm just going to put in negative 8. Did I get anything? Mm-mm. Maybe I need, we put 4x plus 3 equals 4x minus 5. I'm going to put y. I wonder if I can do h of x. Let's try that. Yep, it worked with h of x. H of x equals negative 8. So if you look at this graph, it does not cross or touch the x-axis. That's why the answer is no solution. So that is the lesson for this week. I hope you have a wonderful day, and I will see you the next time.